Hi everyone. Today I would like to discuss about this seeds dataset. So these are seeds dataset in TXT format. You can see. So I downloaded it from Kaggle website. So I'm using Python Jupyter Notebook for this. So model I'm going to use here is logistic regression. In model building we have different steps. So I'll show you those steps. What we have. Uh, first step is null values handling. Next feature selection, model building, checking model accuracy, and deployment. So in this session, I'm considering first four steps, and next session I will consider this deployment related. So first we are importing these pandas, why? Because we are using file handling techniques here. Like we need to use we need to use files, and we need to handle them. So for that I'm using this one. So code I'll give you my GitHub link. You can download from there. So this is the C data. So yeah, it is executed now because here the star symbol will show the execution, whether it is executing or not. The head, this command will show you first five rows of my dataset, so which I uh, loaded into TF. So you can see, and we can see how many are there and how many records are there and how many columns are there. So we have 210 records and 8 columns. I mean 210 rows and 8 columns. And here what I did was I have given namings also. From the Kaggle you can see these things. Uh, when they are giving this dataset, they will tell you about each and every column. So I took the same using this list. I have appended column names to that existing the dataset, and it is a tab based tab delimiter was used because it is a tab delimiter dataset. So it is in text format, I mean txt file. Read csv is the command we need to use here, so it can read your file. I can keep my path here, even though if you are not giving, if it is a unique one, then automatically it can take. So first step, we already loaded the data into our Python data frame. Next we need to see null values handling. After loading, this is the first step. So null value handling we are going to look at now. So this command will help us to look at null values in our columns. So whatever the columns, area column is 1 to 10, null, non-null. Non-null means there is no null value in this, and this is the data type. So perimeter 210. So everything we have fully filled data set. So there is no null values in this, because why I chosen this is the reason we should not have more complexity. I want to show a very simple model building in this. So I'm using very basic one in model selections, that is logistic regression. Why? Because it's a basic one. Any in machine learning or deep learning or anything and related to data science and all, when you want to understand and finding the patterns in the data, definitely we need to go on step by step. That is the same data set and same seed type can be found out based on different models. First model I'm using is logistic regression. Next I'll use decision trees. Next I'll use random forest. Next KNN. The next gradient descent model. So I'll use all types of techniques. Now we loaded the data into our Python data frames. So here seed type is the one we need to find out. So that is an independent variable, that that is a independent variable to be found out based on these independent variables. 7 independent variables and one is dependent variable. So it has multiple classification, that is 1 2 3. So we can see that in C type how many are there and all. Total 210. 1 are there and 70. The 2 are 70 times and 3 are 70 times. So I'm making this as samples. So why I'm making this? It should not be in a manner what they have given. So I made like this. It is in random way. So this is not the first one in our existing dataset. Now I made as 164. It's a random one. So it will select in that way only. Next, you can see the same. Now I dropped independent variables into one data frame and dependent variables into one data frame. So X will have 7 columns which are our independent variables and Y will have dependent variable. So from this X, Y data frames, we are making that into we are splitting that data into two sets. One is training and one is test. So that can be done. This for just checking. So you can check for each and every whether it is how it has divided and all. So from Scikit-learn model, from Scikit-learn, we can download this train test split package. From that we can divide our data into training and test data sets. So you can see that. Just again time. Yeah, now it is executed. So here train will have 147 because by 3 and all. You can see test remaining 66, 63 and 7 columns only we have taken because X data frame we have only 7 are independent variables. Now we are importing this logistic regression package related things and we are just assigning that total model into model name, any variable you can write. So now we are fitting that into, now we are fitting our data into this model. X train is having 7 variables plus 147 records and Y variable will have only Y train data frame will have only one variable with 147 C type answers. So that is based on X input we are getting Y output. So both we are giving as training to our model. These coefficients we can check here and intercept also we can check because logistic regression y is equal to mx plus c, that is a thing. So coefficient and intercept we can have. Now we can, I'm just predicting my existing thing. So if it is 100%, of course it's very much good. If more than 95%, I'm happy with that because it's my first model building thing. Mm. So you can see that array here. Now we can go ahead with our scores. We are downloading this accuracy score here and training data I have given to, whatever the training data I have given to my model, the same training data has been checked again and the score is 93%. It's not good but fine with this model. It's a basic model. Next I'll go with my test data set. So what is the score and all it will show here. So these are output we can think like 1 2 3 only the C types. So you can see that. So you can see our accuracy thing with already we have wide data frame which have already predicted things. Now we predicted here with comparison we'll see. So that is 90%. So this model may not be useful in our production environment, but however as a basic I have chosen this logistic regression. So here logistic regression I have used and score is 90.1%. So what I'll do, we'll go for another model. Next I told you already decision trees and random forest and other things. So if core is better in those models, we'll consider that model as for production thing, and we will go for the deployment. So that's all about this.